Hello, everyone. And on behalf of Fourth Space, thank you for joining us on Facebook and Zoom today for the first installment in a 6-part lunchtime series of presentations and conversations focused on questions of sustainability across disciplines. We are very happy to have you with us here today, and please do join us July 15th, 16th, and again next week, July 21st, 22nd, and 23rd at noon to hear from Concordia students and professors as they discuss the research on sustainability in general and the climate emergency in particular. If you're joining us on Zoom, hello. Feel free to ask questions in the Q&A function throughout today, and our moderator will address them after the presentation. For those of you following along on Facebook, we welcome comments and questions below this video. Again, we will get those to the presenters here. It is now my pleasure to invite Dr. Jim Grant to provide a brief introduction to today's event. Over to you, Jim.
Thanks. Thanks very much. This is, and thank you to Fourth Space, Anna, for hosting this webinar series. So yes, I am Jim Grant. Why am I here, you might ask? I'm the principal of Loyola College and one of the co-directors of the Loyola Sustainability Research Center. And as Anna alluded to, we host with many other supporting organizations an annual conference on sustainability across disciplines. Alas, our 2020 conference was canceled due to the pandemic. But the good news is some of the speakers that would have presented there have agreed to present in this webinar series. And so we're really delighted about that. Let me introduce next Dr. Rebecca Titler. Rebecca is the coordinator for both the Loyola Center, Research Center, and Loyola College. And she's going to introduce our speaker and moderate this session. So take it away, Rebecca.
Hi, everyone. Thanks for coming. Thank you, Jim. Thank you for all of you for being here on a warm July morning, midday. I would like to introduce the first speaker of our series, is Zainab Yousafzadeh, who was supposed to present at our March conference. Zainab was actually the one who pushed for this webinar, which was a great initiative, saying that she had been really excited to present at the conference, the work from her master's, and that she wasn't necessarily going to be here because she's finishing her master's, so she won't necessarily be able to present next year. That is the case for most of the students who are presenting as part of the webinar series. They're either graduate students or honors students who were really looking forward to presenting this past March and won't be able to present next March when we take up the same topic. Many of the presenters who were scheduled for last year will be presenting next year. But this webinar format works really well for students like Zainab who have great things to share. Zainab is doing a master's which she will complete this year. In industrial engineering under the supervision of Professor Shannon Lloyd. Professor Lloyd is cross-listed in the Department of Management in the Business School and in industrial engineering in the Gina Cody School for Engineering here and Computer Science here at Concordia University. Part of the work that, so she does a variety of different types of work. Some of the work that she does has to do with life cycle assessment, which is something that I am always very interested in and my students are always very interested in, and I know very little about. But life cycle assessment, as Zainab I'm sure will tell us, kind of gives us a little bit of an objective way to compare different solutions or potential solutions in terms of environmental footprint or sustainability footprint. And Zainab knows much more about this than I do. Zainab's work falls under the umbrella of the Green Seam Project, which is a Canada-wide network of universities working on surface engineering. And there is an LCA branch of this working group. So without further ado, please join me in welcoming Zainab Yousafzadeh to speak to us today about her work on life cycle assessment and looking at pipe freezing.
Hello everyone, can you see my screen? Hi, could you hear me? Okay.
Looks perfect, Zainab. Go for it.
Okay, good. Hello, everyone. It's a kind of winter talk in this warm summer, I know. My presentation today is the explanation of the initial results and ongoing cooperative research on life cycle assessment of thermal spray coating system for water distribution pipes freeze protection. The purpose of this presentation is to describe the process of using life cycle assessment to identify opportunities for improving the environmental performance in emerging technologies. This research is defined in Green Sim Network under the supervision of Dr. Shannon Lloyd, and Dr. Rezvani and Dr. McDonald from Alberta University are co-authors of this work. As an introduction, in some regions of Canada, many households and industries are struggling with the problem of freezing the water pipes in winter time. Failure to protect piping may cause ice blockage and pipe bursting. In extremely cold weather, this problem causes noticeable financial losses, and using only insulations like glass wool around pipe is not enough. Conventionally, electric heating cables are installed around the pipes to warm up pipes and prevent liquid from freezing. As an alternative, multi-layered coating system, which is developed by surface engineering methods, provide the same functionality, but with increased energy efficiency. The new system consumes 30% less electricity in use phase. These comparative LCA initially aim to answer the question that using which system is environmentally preferable. Heating cable or tracer is a specific cable with 5-layer combination of polymeric and metallic materials. Multi-layered coating system includes 2 coating layers, aluminum and nickel chromium alloy, which are applied by flame spray, and copper for electrical connection, which is applied by cold spray. The life cycle stages of these technologies are shown here. This chart shows all the stages, including material, production, installation, and operation. Electricity is the only input for operations stage in both systems. In our initial LCA, we used the cutoff approach and did not consider end of life as shown here, just transportation to the waste management center. We did this because the lack of data about end-of-life process for these systems, which is the topic of next part of this presentation. In addition, end-of-life is an afterthought for coating developers, so they are not typically designed to be recovered or reused. I hope this video can give a sense of what flame spray look like. Sorry, it is a bit noisy. In this video, the nickel chromium alloy is being sprayed on substrate. The initial study analyzed impact with Alberta electricity mix by assuming 4 months of use these systems in winter. Comparative impact results shows that the impact categories, in all impact categories, human health, climate change, ecosystem quality, and resource depletion, the coating system has less impact, and it is environmentally preferable. The analysis of life cycle contribution make the research more interesting by discovering that the main contributor in both systems is electricity consumption in use phase. By comparing the production phase, it is obvious that coating less impact associated with the less electricity consumption in use phase. The electricity impact depends on 2 variables, number of frost days and electricity mix. Let's start with frost days. What if we operate systems in colder or warmer places? As you see, we have a huge fluctuation in frost days across country, even across each province. In another hand, what if we decide to do assessment in another area like Quebec, which has cleaner electricity mix, or in adverse in Nova Scotia with more consumption of coal and coke in its electricity mix? So in Canada, with a variety of climate zone and energy mixes, the question is, what are the environmental impact of freeze protection systems are used in different locations? Taking into account all these variables in 4 impact categories, the results was calculated again in all over Canada. This map shows in each region which system is more preferable in each impact categories. The blue squares represent cable and the orange ones represent coating systems. First of all, it can be concluded that there is no best system. Second, although new system seems mostly preferable, it is good to notice that in most populated regions like Vancouver, Toronto, and Montreal, we cannot say the new system is 100% acceptable. Based on our findings, we expanded this study to investigate what can be done in 3 areas to reduce the overall environmental impact: pre-use, use, and post-use phases, which is still a black box, and we will try to define some strategies for that. Let's start with the most essential improvement, which is electricity in use phase. Since coating developers have no influence on the source of use phase electricity, we focused on energy consumption. For determining an environmental goal for coating system, break-even point was calculated. Accordingly, the question is, if we want to keep the current production system and just increase electricity efficiency, how much saving energy is needed for coating to be always preferable? This chart shows the amount of required energy saving for each province. The rectangles displays the range of required saving in each province, and the number on top of each rectangle represent the threshold that if saving reached there, the system is environmentally preferable in all regions of a province. Except then the orange zone, that it seems hard to become preferable only by efficiency improvement. In Quebec, it is impossible, and it definitely requires substantial improvements. And therefore, for the coating system to be environmentally preferable across Canada, advancement in production process and recycling are needed. From a pre-use or production perspective, in parallel, we are looking at lifespan, material selection, process improvement, and multifunctionality, and their influence on impact. However, in this presentation, I do not focus on them. Finally, from a post-use perspective, we are investigating end-of-life options. First, we are trying to understand the expected outcomes. For example, if a coating is damaged in a field, could it be repaired? If so, what are the options for repairing it? At the end of life, what would be expected? Would the pipe system be landfilled, or would the coating be removed from the pipe? If the coating is removed, we can assume that the steel pipe would be recycled, but would the coating be recycled too? Second, we are investigating viable options for recovering and recycling the coating so that we can compare and contrast the impacts from feasible outcomes, not just the status quo. There are a variety of coating removal methods. Our recent focus has been on investigating the feasible coating removal options. There are 3 general categories of removal methods: molecular disassociation or chemical methods, impact or mechanical methods, and thermal methods. Let's take a closer look at each category. Molecular disassociation is referred to those coating removal methods that their process drivers are chemical reactions. Chemical methods encompass immersing, brushing, or spraying chemical agent on the item with the purpose of removing its coating. The chemical agent can be acid, alkaline, or neutral, and the most famous application of chemical methods are pickling, descaling, and paint removing. chemical methods are the reverse version of electroplating. In electroplating, electricity is used for binding the ions like chromium to substrate, but electrochemical stripping aims to remove molecules from the substrate. In impact methods, we aim to abrade coating from substrate with a mechanical energy. While there are traditional impact methods like scuff papers, grinding, and machining, the important group of industrial impact methods are abrasive blasting techniques, which can be divided into dry and wet blasting. In some dry blasting technologies, air pressure is used to apply abrasive media to the surface. In another systems, centrifugal power of a spinning wheel is used to blast abrasive materials. Also, there are vacuum blasting systems that make it possible to gather the dust and abrasive materials and then separate them. In a group of wet blasting technologies called hydrojets, the high pressure water is used as abrasive media. In other systems, the nozzles are designed to make it possible to add abrasive particles to increase efficiency. In another wet cleaning methods, the ultrasonic vibration of water is utilized for cleaning the surface. Most important thermal methods are laser ablation and thermal decomposition. In laser ablation, a laser beam is focused on a coated surface to remove material from the irradiated region. Laser ablation involves complex, nonlinear physical chemical mechanism. Thermal decomposition is referred to the method in which chemical decomposition caused by heat. In this technique, by using infrared or laser, the coating is heated up and removed from the substrate. We aim to screen all removal methods to find technically feasible methods, financially accessible technologies, and among them, most viable methods. Accordingly, we are in the process of interviewing subject matter experts in the field to understand the feasibility of each removal method. By doing so, we are investigating the criteria includes possibility to separate coating and substrate, substrate damage level, possibility of collecting the removed coating and separating coating components, degradation level of coating components, market for scrap coating, and substrate. Once we identify a set of viable methods, we will then update our LCA to include these recycling strategies. To summarize our finding today, for this case study, use phase electricity is very important. In areas that use non-renewable electricity, the novel coating system has a lower environmental impact. In areas that use renewable electricity, we must focus our attention on reducing impacts from production and end of life. End of life has generally not been considered in the design of coating systems or in LCAs of coating systems. As a first step, we are updating our LCA to compare and contrast different feasible methods for recovering, separating, and recycling the coating materials. Future work can then look at selecting materials and designing coating systems with the intention of keeping these materials in use with the lowest impact on the environment. Thank you, mostly from Loyola Sustainability Research Center to give me this chance to present my work.
Thank you, Zainab, for that really interesting presentation. Coming from someone who knows nothing at all about this field, I find it fascinating. I always kind of assume that there are people out there who can tell us the answers to our, which choices we make in life. I'm just not one of those people normally, but I'm glad that there are people. I have a question. Let me see. Oh, okay. I have a question from me, if nobody minds me starting off, unless anybody else wants to start. Okay, I have a very basic question. So my very basic question is, do we have these types of things in our houses? Or is this something that we're talking about industrially in terms of the multi-layered system versus the heat cable system? Is that something that a decision that we can be making on an individual level about I feel like I should know this as a homeowner, but I don't, about, you know, how we insulate our own pipes, or is it something that is coming from industry?
Mm. Thank you. It's an interesting question, but as you know, the coating system is an emerging technology. It is not in the market now, and this is the example of introducing a product to the market that after this people may select this to use it, and if one of our problems in this life cycle assessment is we don't have any practical result from the using this actually in the for example in a house in a city, and it is kind of what if assessment, and what if we want to promote this system, and what is the environmental impact. And for now, this I think you can select this coating system, but maybe in future the developers of this system can introduce their work to other people.
But the heating cable system, is that something that we already have?
Yes, this is a conventional method for protect pipe from freezing.
Okay. Anybody else? Yeah, Jim, go ahead.
Great talk, Zainab. A question, do you see this technology when it develops, will it be more important in new construction, or can you retrofit my old house which had freezing pipe problems? How do you see that? Would a plumber be able to go to his plumbing supply place, his or her plumbing, and pick up one of these pipes? Or is that how you see the technology being applied?
Actually, this technology with the methods that they want to apply it is the thing that you should have the pipe with the coating system. It's kind of pipe with this protection system on it. It means that in future you may buy these pipes when you construct your pipe distribution structure with the pipes that they have the protection system on it, and it is not like cables that you can put it after having the hose for many years.
I have another question. I'm going to dominate here. So I'm always interested in what goes into the life cycle assessments. So I was looking at your impact categories and wondering particularly about two of them. What goes into the human health measure? So are we talking about just the health of the workers who are putting the coatings on the pipes, or are we talking about people who are working in mines collecting the materials? How far does that measure go?
If I can share again my one of the slides that I have here, it makes a better understanding of in impact assessment. You can see here my screen. Human health is let me, what's that? Sorry. Okay. Human health is a sum up of the impacts of some midpoint areas like human toxicity, respiratory effects, ionizing radiation, ozone layer, and some other things that I just show some amount of them. For example, ecosystem quality like that. We have photochemical oxidation, aquatic ecotoxicity, and yeah, this is the damage that from these midpoint categories. Did I answer your question?
Yes, more or less. I could follow up, but I have a question for somebody else so that I don't dominate. So I have a question from Alex Matveyev, who asks about these coatings. Do they essentially work electrochemically, i.e. as a battery, and do not require external power sources?
The electroplating, it is a cell. It's like a cell. You put anode and cathode in a electrolyte, and the liquid between these two electrodes make it possible to transfer the ion from one electrode to another, and the direction of the transferring the ions is determined by the which electrode has the positive current and which one has the negative one. And yeah, this is the action of the cell, the battery, and we use it in different practice of the industrial practice for removing the coating or applying the coating.
So you don't plug it in. There's
Sorry?
there's nothing to plug in. You don't have to have an outlet.
Okay.
Alex, does that answer your question?
Yeah.
Yes, he says,
Okay,
I see. Great,
good.
thank you. Do we have any more questions from the audience?
Me?
One little follow-up from Alex. Hang on, he's typing. Oh, Jim, do you have a question you want to ask in the meantime, and then we'll come back to Alex?
What do you think about a third alternative? In my old house, I had a freezing pipe. We used to leave the water dripping, which is probably really bad. But any thoughts about the environmental cost of that? Would that be an easy calculation to do?
It is related to freezing the pipes.
Obviously, I didn't have a very serious problem, but a little bit of water was enough to solve the problem. But anyways, that would not help for an outdoor pipe or a pipe that really froze nastily. But anyways, something to think about.
Yeah.
As a third option.
Yes.
Okay, thank you.
Thank you.
Okay, from Alex, the follow-up question is the direction along the pipe or perpendicular for the current?
Sorry, I think I didn't get the question.
He asks, is the direction along the pipe or perpendicular? Is the direction of the current along the pipe
You
or
mean
perpendicular to the pipe?
You mean about the electroplating
Yes.
or something? It is not the conventional way to right now. It is, as I mentioned in my presentation, we don't the end of life process, the removal method is a black box for us. This is the thing that we are investigating now, and we want to see which method is more feasible for this system. Because of that, I don't think that we can remove the coating with the electrochemical stripping. And maybe as an initial research that I had, it is mostly possible to remove it with blasting, with abrasive blasting. Because of that, we don't know this is feasible for this case or not. And I don't have a clear answer for that.
Okay, Alex, does that answer your question, more or less? All right, well, if there are no more pressing questions, we're about at 12:30, so we're just about out of time. I'll take maybe the last minute to thank the Force-Space for helping us host this, and Zainab, especially for you for presenting, and to welcome and all of you for attending as well, and also to invite you to remind you that this webinar series is going on for tomorrow and the day after of this week, and then Tuesday, Wednesday, and Thursday of next week. So wherever you found information about today's webinar, you can find information about the rest of the webinars as well. Tomorrow we'll be hosting Cedric Yargo, who's an honor student in the Department of Geography, Planning and Environment, working with Norma Rantisi on privately owned public space, looking at an assessment of Montreal legislation and projects. So quite a different issue, and the issues do vary quite a bit from one day to the next. So stay tuned and check them all out on the website, Loyola Sustainability Research Center. You can Google us, and the events are just at the bottom of the webpage. Thank you all so much for participating. Anna, do I need to, am I turning it over to you here? Okay, so I'm going to turn it over to Anna Waklavic from the Force Space just to close us out here.
Thanks very much, Rebecca, and thanks for sharing all of that news. You did my job for me, which is great. So I'll just take a minute to thank Zainab for sharing your research. It was really enlightening. And on behalf of all of us at Force Space, I would like to thank you all for being here, Jim, and especially Rebecca, Dr. Rebecca Titler, for moderating today's event. Very well done. A recording of today's event will be available on our website, which is concordia.ca/4 very soon. And it also lives on Facebook now, so you can check it out there and share it at CU Fourth Space. On that note, thanks everybody. We appreciate your participation. And as Rebecca mentioned, we'll see you tomorrow for episode number 2 in this series. Enjoy the rest of your day. Bye.